We're about to begin the data quality management presentation. Our speaker today is Rene Spronk. Rene Spronk is a professional trainer focused on interoperability standards such as HL7 v2, FHIR, IHE XDS, and DICOM. He has over 25 years of experience in HL7, and he has been involved in FHIR since its inception. He provides training courses and presentations mainly in Europe. He is an active supporter of the HL7 implementation community and acts as the facilitator for the community track during the FHIR DevDays. Rene was the one who proposed the acronym FHIR, and as such gets blamed for many FHIR jokes. However, if we will look at the success of DevDays, the name has surely helped everyone get all fired up. Rene, are you set to present, sir? And I think you're muted, Rene. Let me see.
There we go. Yes.
Fantastic.
Participants are not allowed to unmute themselves, so that's a bit of an issue there. Anyway, so yes, welcome. And perhaps without further ado, let's indeed look at data quality management. So for my part, welcome. So indeed, yes, Rene, and I've been a trainer for a long while, and also when it comes to the FHIR specification. And each and every Dev Days, I try to tackle some new subject area that I don't know a lot about in order to teach myself and in order, obviously, to also then teach others. So data quality management, let's look at that today. And you've seen the scope and agenda, and that's probably why you're here. So I'm not going to repeat that. But yes, data cleansing is something that we need in quite a lot of scenarios. So in terms of agenda, final bullet on this slide, yes, we're going to look briefly at the ETL process, at cleansing, at mapping, at validation, and data quality metrics that you may wish to use. And actually, this presentation came out of the realization that when you're importing, let's say, FHIR resources from some application A into your own application, and you're going to persist those resources, you will have to merge those with what you already have. So issues around de-duplication and reconciliation and merging and validation is something that is the name of the game that you need in almost all scenarios. But also if in a more classic environment where we have ETL, extract, transformation, and load, where we basically more in a batch-like fashion wish to import sets of data from various sources, that's a very classic data warehousing effectively, then you need such processes as well. Cleansing, transformation, validation. And in this presentation, and I'll revisit that, in this presentation, we're assuming that everything is fully FHIR enabled. So all of the applications that we have here are fully FHIR enabled. And yeah, I'm very much aware that in real life, that may not always be the case, very likely not to be the case. But hey, this is the FHIR Dev Days, and you can probably translate some of these things that I will be discussing today within your own environment, even if only one side is FHIR and the other side of your integration is, let's say, a relational database, which is what it typically is. So data quality management is a set of practices, but also governance rules. It's not just technical stuff around FHIR, but there's a lot of governance rules around there to maintain or increase a high quality of information. What does that mean, quality of information? Well, it's in the eye of the beholder. So it's the receiver's ability to actually serve, to use that for some specific purpose. So data quality management is not something that you can just willy-nilly apply to any data. You have to be aware of what sort of purpose is that data going to be used for. And in that context, you can probably define some quality criteria that in that context, I want the data to have these specific criteria. So it's fit for purpose, the best fit that we can have for a specific purpose. There is no such thing as a best quality ever without knowing the context of the data. You can spend a lot of effort effectively in trying to increase the quality, whereas that may be totally irrelevant in the context that you're dealing with. Now, this is kind of also of an agenda. Data quality management, yes, you will have to define quality rules in a particular context for a particular use, right? What are the business rules? Or indirectly, perhaps, what FHIR profiles should this data comply with? FHIR profiles are effectively an expression of a set of data quality rules, if you want. Then typically you then apply to this data that you receive from somewhere else or that you extract from somewhere else, perhaps using the bulk data API in FHIR, if you know about that API. And then depending on where you look at this sort of data control techniques, and some sources use a 7-step approach and others have only 2. And here, just for convenience, we have grouped those in 3. You can group them willy-nilly, but here in this presentation, we've created 3 groups. Data cleansing, okay, to correct inconsistent or incomplete data in as far as we can detect that and indeed cleanse or correct that using third-party sources or terminology servers or whatever. Mapping, so if we have structural differences perhaps between the source and what the receiver wants to process, then it's going to be a mapping process. And this could be from one format to another, but also things like aggregation. We have 2 different resource types on the source server, but the destination only supports one of those, sort of an amalgamation of the content of the 2 resources that we had on the source system. And finally, verification. And verification is validation. So to see whether the data is now fit basically to be used in a particular context. Now, quite often this is done near the end of this quality control technique pipeline. It's more like a pipeline, but not always. So this does not suggest that it always has to be done in this specific order. First cleansing, then mapping, then verification. Actually, the sequence could be somewhat different. During this entire process, but also over time, let's say you're processing data from a source system over a period of 5 years, you want to actually make sure that, using some quality metrics, that you also influence the quality of the data in the source system. The best quality management is not to do it once you have extracted it, but to actually improve the quality of the data in the source system. That's obviously the best way of doing things. However, that may not always be possible. You may have no power basically to influence that source system. Anyway, so you need to define these quality rules. What are the quality rules, the business rules effectively that you want the data to apply to once you have done all your transformations, etc.? And it could be business rules, could be governance, could be legal requirements, regulatory requirements, but it could also be expressed as FHIR profiles. But be aware, however, that, for example, if you are working on a US project and the US project states that, okay, well, we want all of our data to be conformant to US core, the US core set of profiles. However, that may be an overarching profile, but maybe you as the receiver, when you're going to process that data, you may actually not need that full set of requirements as expressed in US core. So you have to differentiate between, let's say, the FHIR profiles that have been agreed upon, let's say in the scope of a particular project. But within that, you may actually, FHIR profiles are fine as a starting point, but actually sometimes they may be too restrictive. You will probably as a system be able to even process something that has a lower data quality than US core. And you never want to basically throw away data if you can actually use it. So be aware that profiles are not the end all basically, but they are, yes, they are an expression of a set of business rules and legal requirements. You want to have traceability. So when you make these modifications, data cleansing, mapping, whatever, you want to have full traceability of any modifications you make to the original data. And this is known in FHIR, as you probably know, as capturing the provenance of the data. And the origin of the data is relatively easy to track. In each and every FHIR resource, we have metadata. So we can use the source field in meta.source, and meta.last updated. And that's kind of serves as a minimalistic metadata as to where did the data come from and how recent is this? How recent has the data been created? If you need more than that, for example, if you're doing transformations, what transformation have you done based on what rule effectively? You may need a full-blown provenance resource. Now, it's not heavily used in all sorts of projects, but it's a very nice FHIR resource that can be used to track all sorts of changes that have been made to other FHIR resources. And once you, obviously, when you create a new FHIR resource, we're assuming here that we have multiple FHIR systems in this presentation. So when you receive a FHIR resource and you basically post that to your own persistence layer, then that persistence layer assigns a new logical ID. So you may, as part of the metadata and as part of your provenance data, wish to have full traceability to the original ID as it was on the original system. And again, a field like a meta.source can be used to at least minimalistically do tracking and tracing on what was the ID of this information on the original system. But it could be done actually using this provenance resource. So then you're going all out and you have the capability of basically storing lots of detail on, let's say, a transformation that you have done. And even nicer than that, if your FHIR server supports versioning, and remember, most servers don't actually support that, but then you could have the prior version of the resource, the current or new version of the resource, both linked to by this provenance resource. And we can actually have the agent who actually decided or made the change. Now, this could be a software application modeled as a device, but it could actually be a human who decides to perform a certain transformation or cleansing step. The activity that was done by creating a new version based on this old version, well, the activity itself could be here, okay? Using some sort of code you can identify based on a certain policy. Let me go back. That's referred here. So these two are indications as to why we have done a certain step in our pipeline and also what we have done in terms of cleansing, for example, or mapping. So provenance, very powerful if you need to basically go for full traceability. Now, as I said, I divided the activities in the pipeline in 3 categories, and the first one was cleansing. Data cleansing. And an obvious one in the cleansing category is I have missing data. Some stuff is missing that I regard as very useful. And what are the ways basically to deal with that? Well, sometimes you can just populate them with default values. If you are in certain departments, then you know that we're only dealing with females and hence the gender is female, even if it's missing. There could be special values that indicate to the receiver that, hey, there is a missing value. Some terminologies have specific codes that mean unknown, or we have a data absent extension that shows us the reason why a normal value is absent. And even John Doe, as a fake name for the unknown patient, is effectively stuffing a data element with the default value. Better, obviously, would be to populate missing data with master data. So you basically use some sort of registry, some sort of reference thing that you have out there, and basically use that as a system of record or a single source of truth to basically add additional data that's missing from the data that are received from some source. Let's say I receive only a patient identifier or a social security number, but I want to basically in my database have a full-fledged name, address, telephone number, and everything. Well, hopefully I can go out to some sort of patient registry and basically pull the data from there. Or if we have, as we will see, if we have a code somewhere from a terminology, but there is no description, there is no human readable text, no narrative associated with that, go to a terminology server, fetch that particular description, and add it to the data. Now, there's been a lot of thinking. This is a very common thing to do when you do ETL type of processing, and it's known as master data management. And you can do quite a lot actually with this. But obviously, this presupposes that you have such registries that you can basically base your enrichment on. Terminology servers are basically an example of such master data registries. And you can add code translations. So let's say the source uses LOINC, whereas I want to use SNOMED. Then obviously using a terminology server, you can add SNOMED, thereby enhancing your perceived quality of the data because, hey, it needs to be SNOMED for me in order to process it. We have the preferred display name. And the preferred display name is quite often language specific. So if the display name is in a different language than that which you desire, then you can just do a lookup. And another example are the patient-friendly display names. And there you see that context is of ultimate importance. Because, hey, if the receiving system is going to basically be a patient-facing application, then you may wish to replace the more clinically display names with patient-friendly display names. And again, something you can do, cleansing of enrichment in this case, based on master data. Now, in general, when you look at FHIR resources, then you know that the rule is that there should be narrative. It's not shall, but it should, which means that effectively that should always be there, and you have to have a very good reason not to have narrative. Now, narrative in this sort of processing, when you're doing research or something, may not always be that relevant. But anyway, you can obviously populate the narrative by looking at the structured data, the data elements, and then generate effectively some narrative. And that's fine. That actually works pretty well. But it could also do this the other way around. And this is actually what a lot of people with an IT background prefer. We have narrative, and narrative is something that's very easy for people with a clinical background to create. And then from that narrative, basically derive individual data elements or entire new resources. The thing is, however, and that's why we are still a bit hesitant right now, is that when you do this, then you need to accept a certain error rate. I mean, these processes are not perfect. So you will certainly in Provenance have to establish that a certain resource or a data element was created by an AI algorithm, for example, and not created by a human being. There's a link here near the bottom near some open source stuff on doing this sort of transformation. And here we see an example where on the left-hand side, this was on IBM Watson Health, so where we had a FHIR-based operation, and the input is a parameters resource with a text, value string, as you see, and the output of the operation was a set of resources. So effectively, we are transforming, if you want, the narrative into, in this case, a bundle of multiple FHIR resources. It's not shown here, but obviously the resulting resources are tagged as being created or generated automatically. So you have full traceability on that. Now, another thing that we saw in some projects was that sometimes the source systems do not have certain references. So let's say you have the graph on the right-hand side. We have an encounter, between April 2nd and April 10th, between patient Eve Everywoman and the organization Alpha Hospital. And we have an observation on April 4th, which is in and of itself within the time interval of the encounter, created by a practitioner, Harold Hippocrates, who actually works for the Alpha Hospital. So now the big question is, looking at this graph of FHIR resources, can we now enrich this data by adding explicitly this deduced effectively reference? Okay, because quite often in quality measures, and this is where this discussion came from, you want to know whether observations of a certain kind have happened during encounters with a certain department, for example. But then if this reference is missing, then the data is pretty useless. So is it safe to assume that if the observation was done during the time interval of the encounter, that we can then deduce this reference? And that's not actually an easy question to ask or to answer, because the observation could have been done in the context of something that was related to some entirely different thing. So you have to define rules around this, whether or not you can basically do this. And this is actually done by a couple of systems that I know of. Now we have deduplication and reconciliation. This is going to be one of the main things. Patients, duplicates, provider duplicates, organization duplicates. As you probably know, it's very easy in FHIR to create duplicates. So the avoidance of duplicates based on business identifiers in any FHIR implementation basically is a pain point. And it's something you have to be very aware of. In a certain way, in conditional FHIR operations are relatively helpful, because then you can do posts or puts effectively only if based on the business identifier, and thereby avoid the unnecessary creation of a new FHIR resources. One very specific problem is decontainment, because sometimes you have contained resources. You're probably aware of that. For example, if you have a prescription and the prescription is about a certain medication, then the medication resource is embedded, contained within the prescription resource. But it could very well be that the receiving system doesn't really like contained resources. They find this medication resource so important that they want to basically take it out of the resource and deal with it as an independent resource. That's not always possible, and there are lots of caveats around this, but sometimes you have to do decontainment of contained resources. And you don't have a solid business identifier for them probably, so it's a rather interesting challenge, I can tell you. Anyway, cleansing, yes, you can look at that from the FHIR perspective, as we have done in the previous slide, but you can also apply pure statistical methods or use AI methods. So when you have outliers, and this could be the value of any data element, well, doesn't really fit with all the other data that we have. So this could be a detection of an incorrect value. And again, you may wish to detect that or flag that because then somebody can correct it. And this could actually be a manual correction process. So just put a flag on the FHIR resource that please inspect or correct this FHIR resource, and then somebody will have to manually do that. Not a preferential way of doing stuff, but certainly just using raw statistics. You can do this for values in data elements, but you can even do analysis on the resource itself. With that, I mean that you can see that, well, in all the condition resources that this system sends, they, in 99% of the cases, they populate this data element. But here we have a resource that doesn't have that particular data element populated. So maybe we need to flag that, because maybe that's questionable as to why did they leave that data element empty, whereas they normally actually populate it. But again, that's pure statistics without any doesn't really require that much in specific FHIR knowledge. Now, sometimes cleansing is also a bit of enriching for queryability. So you know that the data, when you import it, especially in a data warehouse, you're going to have to query that for analysis purposes. So you may wish to do stuff like, well, all dates and times, for example, you could replace them by a date range from to. And that eases your queryability of the data. And as you know, with date ranges and time ranges, there are issues around precision. So what you can do is basically create this date range and have all dates and times expressed in the exact same precision. And again, that makes queryability much easier. Or another example is address standardization. For example, by default, add geocoding to all addresses. So whatever resources you have, if there is an address in there, we're going to enrich that with geocodes. And obviously that again allows you to do more of geographical research on the data. And another thing that's in the same area is the references. Could be relative URLs, could be to contained resources, etc. So some systems actually remove or replace basically all references by absolute full URLs. And if they cannot resolve the URL, then it's garbage and it just needs to be removed because it's a sign of low data quality. Now, as part of cleansing, you may have to do de-identification or anonymization. And that's a topic in and of its own. So we're certainly not going to cover that in detail. But it's basically the process to make it very hard, preferably impossible, but to make it at least very hard to re-identify the patient. But this again, just like basically data quality management, is something that's highly contextual. So if you know how the data is going to be used, then in that context, you can probably de-identify. But there is no such thing as doing de-identification and anonymization in general without knowing how the data is going to be used. Okay, so definitely not a trivial thing, but it could be very much part, certainly in the research environment, of the cleansing process. Finally, and that's why we have it at the end of this cleansing section, is the removal of unusable data. Because even if you try to enrich this stuff, you're still going to detect data that is still garbage. And there is really nothing you can then do, just then throw it away. Or notify at least perhaps also the source of the data that, hey guys, you have some crappy data sitting here and there. But you're always going to have a certain percentage of data that's beyond hope, effectively, of repair. So we have cleansing, enriching, and then we have mapping. And that's a much shorter section. Because again, mapping, there are other presentations during these DevDays that focus on mapping and, for example, the FHIR mapping language. And quite a lot of people use tools like Cloverleaf or some of the other industry standard translation tools, basically to translate. And you can certainly use one of those. Most of them support FHIR nowadays. And well, mapping can also be code translation. I mentioned going from Loing to SNOMED, for example. And that's part of your mapping process as well. But mapping is a bit out of scope for this presentation. But yes, you will have to do mapping. And I specifically wish to draw attention to aggregation and summarization. Because if you know that the receiving context desires a certain level of granularity, or that they only support certain resource types and not others, then you may actually have to aggregate or summarize. Example that's mentioned on this slide is, well, what if we have lots of observations and these observations are a clear indication of diabetes mellitus type 2? And the receiving system says, well, I don't care about the observations, I only care about the condition resource. But obviously you need to have a bit of molecular knowledge somewhere to be able to detect that these observations are typical indications of diabetes mellitus type 2. So I can translate this whole bucket load of observations into one condition effectively. Then we have validation. And validation, and there are other presentations on this subject as well, but validation certainly against FHIR profiles. Terminology validation, that if there are business rules that state thou shalt have SNOMED, then obviously you have to validate that. Is this a valid SNOMED code in this context? Business rules validation, and business rules may not actually be expressed in FHIR. Structure definitions or something. You may have some rather strange business rules out there. So you have to use some other means basically of validating them. Validation against master data registries. So if you say you have to comply with US core, then obviously you can also validate the content against, not just the structure, but the content against a master data registry. And some FHIR servers already do this, referential integrity, that if there are references in the data, then obviously the references have to work. Otherwise it's crappy and we'll have to do something. Now the thing is, some people rely way too much on profiles. They assume that senders are always going to include the profile, the URL of the profile in the meta information. Whereas it's actually a much better recommendation to actually start discovering the applicable profiles by looking at the resource. Effectively reverse engineer the appropriate resource by looking at a resource instance. For example, if you know that you're in the US and somebody sends you an observation with a line code for blood pressure, you know that a US core profile for blood pressure applies. And you're going to apply and validate against that particular profile. Now, this is a bit counterintuitive, that do not rely basically on the profiles that are listed in the meta data, but there has been rather lengthy discussions on this on chat.fhir.org as well. So this tends to be a bit of a best practice. Talking about validation, terminology. Validation against value sets. And well, again, separate presentations on that, so I'm not going to reiterate that. In general, what we see is the validation strategy that's used in this sort of context, that what we see is that quite often people use sort of a rather sanity check. It's not a full-blown validation, but it's some, for example, they use XML schema. Well, I can tell you, if you use XML schema, then you're validating the basic structure of a FHIR resource, but you're certainly not validating a lot of the rules that you have in structure definition. But is it good enough? Well, in some circumstances, that's actually good enough. Sometimes you see that systems basically do a basic check on import and then do full validation upon export. Okay, Postel's law, be flexible in what you receive and be precise in what you actually send or export in this case. And full validation, with that I mean use one of the production strength validators, the Java one or the .NET one. So certainly when you do validation, then flag stuff that's wrong. You can use meta.security, one of the security labels, to do that, or meta.tag. And there is an error detail extension that you can basically slap on all the data elements that we have in FHIR. So there's plenty of ways basically of labeling something as being erroneous. But remember, rejection of data may not always be an option. I once heard a story of a US cancer registry, and they basically, there was no legislation or nothing basically to force healthcare providers to send them any data. So they were begging on their knees, send us anything, send us a fax or a spreadsheet, or we don't care. We accept anything, or we accept everything rather. So you may not always have the option of rejecting the data. The best way of improving quality is improving the quality on the sender side, right? But that you may not always be able to basically achieve that. Now, in general, when you deal with data quality techniques, then you may need to have some data quality metrics. How do you measure the quality of the data? Well, you could define some FHIR-specific data quality measures, or does it comply with FHIR profiles and that sort of thing? This set of data quality metrics is pretty generic. They would apply basically anywhere, also to FHIR. So what's, for example, the error rate that we are detecting when we're validating? And does it go up or down? Because if the error rate from a certain system continuously goes up, then obviously we have a bit of a problem. So to summarize, with about 10 minutes left, also for Q&A, there is one question currently in Q&A, feel free to ask. So yes, you have some architectural options when it comes to this sort of process. You can do the cleansing and mapping at load time, so when you import the data, and this is classic ETL, or you can do the cleansing and mapping when somebody queries for it. So basically you receive some garbage from some data from somewhere else, you just store it as is, and you basically only perform the cleansing and the mapping, etc., when somebody queries for it. That's mostly known as a data lake ELT, but they're basically just variations on the same theme, and you perform the same sort of steps. Definitely perform some sort of sanity check. Perhaps not a full validation, but certainly a sanity check. But also, for example, on birth date. Birth dates may not be in the future and that sort of thing. That's part of your sanity check. And mostly you see that these systems are defined or implemented in such a way that they're idempotent. So effectively you can run the same pipeline of cleansing, mapping, etc. Again and again on the same data without there being undesirable side effects. Good design characteristic in this case. Now, as I said, these slides are purposefully limited to FHIR applications. These are the FHIR DevDays, and otherwise we'll have to talk about graph databases and relational databases and what have you. But as I said, a lot of the steps that I discussed here, although I discussed them in a FHIR type of flavor, they apply one-to-one when you're transforming to different data structures as well. So final slide summary is a set data quality management, a set of practices and governance rules to maintain high quality of information. Best done within source systems, as I pointed out. Cleansing and enriching lots of possibilities, lots more, even more than I presented here. And certainly monitor the data quality measures over time so that you can actually see the data that the quality of the data that you're collecting, as well as the quality of the data as you are receiving this from disparate sources. So let's have a look at our Q&A, and I will, by the way, I will also respond to those after the session so that it's kept in the archive. How do you recommend capturing accuracy, standard deviation on observation.value quantity? Good question. Actually, I don't know. That would be a very good question for chat.fhir.org, as I don't see this related to the quality of the data. I know why it's related, obviously. But that will be some detail for a group like Orders and Observations within FHIR to the FHIR community to comment upon the precision of data versus the quality of the data. So I understand the question where it's coming from, but I don't know the answer. Is there any books about data quality management you can recommend? Well, if you go to Amazon or something, you will find thousands of them. And it very much depends on what you're wishing to do with it. So what I've done here is basically grabbed some of the key concepts in data quality management and try to put a bit of a FHIR sauce on top of it. But I don't have any specific book to recommend. There could actually be viewers here of this presentation that may wish to comment on this one as well, whether they have anything to recommend. And then the final question, how best to detect duplicates in FHIR? I think de-duplication, which is an area I touched upon, is a very hard subject. And business identifiers are obviously the best way. But you know that, for example, for patients, we have these very specific applications, master person indexes, for example, that try to do matches on birth date, on partial name matches, and so it gets relatively hairy relatively quick. I always use the example of Huey, Louie, and Dewey Duck, okay, living at the same address, probably born on the same date, and then it gets relatively hairy. You have to realize that, let's say we're populating a FHIR-based repository with, let's say, data from HL7 version 2 messages or from X12, then these messages don't contain any business identifier. So quite a lot of things don't have any business identifiers. And then how do you detect a duplicate? If somebody is allergic to penicillin and I receive another allergy and tolerance resource for penicillin, is that a duplicate? From a clinical perspective, that's probably not a duplicate because it may have a different clinician as its author. So there is no easy answer to this, unfortunately. But de-duplication, in my mind, if you're dealing with multiple data sources that are overlapping in scope, is one of the key things that you have to deal with. But remember that this is in no way FHIR specific, this problem. This problem will occur wherever you have interoperability in place between multiple systems with overlapping scope. Let's see, the last question by Nisha Bose. If we have extra fields which we cannot map to FHIR standard, then shall we go ahead and store it into any of the FHIR resources field? Well, that's a very generic FHIR question, and that's why we have extensions, right? Extensions cover everything that does not fit within the standard data elements in the FHIR resource. In general, it is recommended that if you have FHIR resources with extensions, then to persist the value of those extensions as well, even if you as a receiver don't know what the extension is. But remember that in this context, what we spoke about here, data quality is always in the context of some purpose. So somebody wants to do something with the data, and that's what we're going to optimize the quality for. So an unknown extension, if you're receiving that and you know that the receiver has no use for it, in this context, you can strip it out, right? But the extension mechanism would normally be used and not basically misuse any of the other fields that are meant to be used for a different purpose. Right. So I see no more questions in the Q&A. So with that, I'd like to thank you for basically attending this topic, which doesn't really show up that much actually in the context of FHIR DevDays. We've had a few presentations on this topic in the past, but it's probably well deserving of your time to give this some thinking, because obviously this type of problem occurs in quite a lot of FHIR-based projects. So thanks again, and I hope to see you again at one of the other sessions or presented by me and or by one of the other interesting speakers. So thanks again, and maybe see you in the bar or at some other social event. Thanks again.
Fantastic. Thank you, Rene, for the wonderful presentation on data quality management and for answering all those questions. And thank you all for attending. This will conclude the data quality management presentation. Thank you.